Hey everybody. Lots of exciting stuff got done this month. I implemented ranged weapon functionality, added some new stats, and finally got around to adding config options for some of the more extraneous features of the mod. Let's get started. If you remember back in the first devlog when I was first adding elements to the game, I briefly mentioned how damage sources work in Minecraft. When you attack something in Minecraft, all the information about the attack is stored in a little bundle of data called a damage source. The damage source is then sent over to the target of the attack so they can decide how to handle it in damage calculation. Ranged weapons are going to work in roughly the same way. First, we need to take the damage info from the ranged weapon and store it in the projectile. Then, once the projectile hits the target, we use that info in the damage calculation. Sounds simple, but how do we do that? I'll start by making a way for data to be stored in a projectile. In Minecraft, all projectiles are subclasses of this abstract class called projectile. So by storing the data here, we'll be able to read and write damage info for any specific projectile we need to. Now that a projectile is able to contain damage info, the next step is to take the ranged weapon's info and store it in the projectile. Unfortunately, here's where we run into some complications. To summarize the issue, I want to add code somewhere that takes damage info from the ranged weapon and stores it inside the shot projectile. The brute force, kind of obvious method would be to just go over all the ranged weapons in Minecraft, check their code, and find a solution for each of them individually. Apart from the greater time investment this would take, any ranged weapons from other mods would also have to be manually implemented like this. Let's see if we can find a better solution. The most obvious thing is to check if there's an event that fires for all ranged weapons, regardless of what the ranged weapon actually is. If you didn't know, events are little markers placed into the game's code by Forge that allow modders to easily run their code when specific things happen. There are two things I need out of an event for it to suit what I'm looking for. One, it must occur at some point between when the projectile is fired and when the projectile hits the target. 2, it must let me access the ranged weapon to take the data from, and the projectile entity to put the data in. Unfortunately, after doing some investigating, there aren't any events that fit what I'm looking for. The closest would be Projectile Impact Event, which fires for any projectile hitting a target, but this event doesn't provide the ranged weapon. In a past iteration of this mod, I had attempted to solve this problem by storing a piece of ranged data in the player that gets updated whenever the player equips a ranged weapon. This ranged data would act as a buffer so that I could use one event to take data from a ranged weapon, and another event to use that data without needing a single event to have both the ranged weapon and the projectile. Then, any projectile shot would use this ranged data from the player. But this isn't a great solution. Just because the player is holding, say, a bow, doesn't mean that every projectile coming from the player is the arrow shot from the bow. What if they're using some kind of mod that adds a spell or something that shoots a fireball? The next best solution is to use Reminiscence, which is basically just skipping Forge's API altogether and editing Minecraft's code directly. This is less preferable because it can introduce compatibility issues if other mods want to change the same code I'm changing. This usually isn't an issue though, so I'm not super worried. Taking a look at the code for ranged weapons though, things aren't looking great here either. In an ideal world, we'd want ranged weapons to all be linked code-wise somehow. Then we could just write instructions for ranged weapons in general instead of each ranged weapon individually, and the code would automatically be applied to any ranged weapon, even from other mods, that links itself like this to this kind of ranged weapon relationship. Unfortunately, this isn't the ideal world. Ranged weapons have no link to one another code-wise as I've just described, which means we still have the issue of having to brute force every ranged weapon manually, which I guess seems like the only option left. As far as I'm aware, there are 3 projectile weapons in vanilla Minecraft: bows, crossbows, and tridents. The silver lining here is that these 3 are in theory superclasses on their own. What this means is that if other mods add bows, crossbows, or tridents, as long as they're subclasses of their vanilla counterparts, our implementation should work automatically. This is the code for crossbows. Each ranged weapon is implemented slightly differently, but the logic is the same across the board. First, we make sure that the ranged weapon has a weapon info NBT tag. Then we'll take the weapon info from the tag and use that to get the attack info for the currently selected attack type. Then just store the attack info in the projectile and we're good to go. The next step is to take the damage info from the projectile and use it in the damage handler. Not too tricky, we'll just check if the entity that caused the damage source is a projectile, and if it is, grab the damage info from it and continue as usual. Now we can do a first test. So an arrow that hit a wolf didn't have damage info. Seeing as I didn't even get to see my screen, let alone shoot an arrow, it seems that the arrow must have been a skeleton fighting a wolf. Knowing this, my best guess is that mobs don't use the same methods to shoot projectiles that players do. Checking the documentation more closely, it seems I'm just illiterate. I guess we're gonna have to add implementation for mobs separately. After a bit of digging, I found this method called getMobArrow that looks promising. It seems to be called for any ranged mob using a bow, and lets us access the bow itself and the projectile entity. Crossbows, it turns out, actually do use the same methods as the player, so we don't need to do anything extra there. As for tridents, there's only one mob in the game that actually uses them, so we just need to change the drowns code a bit. Time to test again. Well, it seems to be working now, so that's good. If I was a real programmer, I would implement a bunch of unit tests to ensure everything is bug-free. But I'm not a real programmer, so I'm just going to assume everything works until it doesn't. Now, some of you may be wondering why I didn't add any code for other projectile mobs like withers, ghasts, blazes, or snowmen. Well, the reason for that is the projectiles they shoot aren't influenced by the mob's attributes, or any kind of held item. This more or less works out in our favor though, because they also all have their own damage types. So we can just use the tagging system I went over in the first video. Here's an example showing how I implement the Blaze's fireball attack using my tagging system. The next thing I want to do is polish a few inconsistencies with ranged weapons. First, tooltips still assume everything is melee, so we're showing stats that are useless to bows like min and max range, attack speed, and attack damage. Second, we need to make sure that bows aren't granting their attributes to the player like a melee weapon would, otherwise bows could just be used as a melee weapon. To fix these two things, we need a way to mark ranged weapons as being ranged. The obvious solution is to just use Minecraft's inbuilt tagging system. It does seem convenient, but I'm imagining it would be really annoying on the user's end to have to keep switching between JSON files for every ranged weapon they come across when designing their ranged weapon stats. Instead, I'll just add an optional field to the JSON file of weapon infos that lets the user denote what shouldn't give the player attributes. The last thing I'll do here is make a quick change to the weapon info generation algorithm to automatically add the new field to any bow item or crossbow item instances. Now that we can recognize which items are ranged weapons, we can fix the issues. It isn't tricky at all to make sure that ranged weapons aren't granting attributes to the player. Just a quick fix here and things are good. Before I go about changing tooltips though, I want to talk about two new stats. Accuracy is a stat that works differently for melee and ranged weapons. For melee, it represents the chance of landing a clean hit. Beyond just hitting the target, accuracy represents edge alignment for slashing weapons and point integrity for thrusting weapons, which is essentially just the ability for the weapon to actually pierce the target and not bend or break. For ranged, accuracy determines how much random deviation there is from the crosshair while shooting. I had actually originally planned on having accuracy as a stat, but scrapped it in favor of custom reticles. But custom reticles turned out not to be as game-altering and exciting as I had thought. I also realized that lethality and damage bonus were essentially fulfilling the same purpose by getting auto-generated based on the weapon's material properties. Instead of using an algorithm to generate a damage bonus value based on a weapon's material and shape like how lethality is, we'll generate an accuracy value instead. Damage bonus will still be a value in the JSON file, but just as a default 0. This is to give users more balancing tools for weapons. Let's talk about what the accuracy stat will actually look like on weapons. These are the formulas we'll use to generate accuracy values for melee weapons. This is the formula for slash attack accuracy, which uses weight and flexibility as terms. Its range is from 0 to 1 or 0 to 100%. Since 3D graphs are a bit hard to visualize, I'm just using a 2D graph with weight treated as a constant. From the research I did, it seems that edge alignment is made easier with more weight behind the blade, and is made harder by the blade being more flexible. So to represent that, I've just made a function here that uses the weight as a starting point and then reduces as flexibility increases. On this particular graph, I've set weight to 0.198, which is actually the value for a diamond sword slash attack. Sliding the pointer along the curve here, you can see what the resulting accuracy would be for any given flexibility value. Just for fun, let's check what the flexibility of diamond actually is. Using that on our graph, we can see that a diamond sword slash attack has 57.5% accuracy. Before I get into what the 57.5% actually means, let's quickly go over the formulas for thrust and strike. In my mind, the chance for a thrusting attack to successfully find purchase is higher with more rigidity in the blade and lower with more flexibility in the blade. So I'll use roughly the same idea as slash and use hardness this time as a starting point, then reduce the function as flexibility increases. Finally, for strike, we'll start with 1 and reduce by a portion of the weight. While this doesn't really mimic real-life weaponry, there needs to be some drawbacks to having weapons with high weight, because right now weight is beneficial to almost every formula we have. Now let me explain how accuracy actually affects damage calculation. Accuracy, as you know, is measured as a percentage from 0 to 100. We'll plot the melee weapon's damage using a normal distribution, where accuracy acts as an inverse standard deviation. What this means is that higher accuracy gives you a better chance of dealing full damage. Since we don't want attacks to exceed their advertised damage, we'll only use the left half of the normal distribution. First, we'll add a new field called accuracy to the information of an attack type. Then we can go to the damage handler and add the calculation we want. Accuracy is a percentage from 0 to 1, so we'll get the standard deviation by multiplying the inverse of the accuracy by the total damage number. So that higher accuracy means a lower standard deviation. This function will generate a number from a normal distribution with a mean of 0 and a standard deviation of 1. Then we just scale this number by our standard deviation from earlier and add it to the damage number. Finally, we'll make sure it can't go over the original damage amount, or below half. Time to test it out. Unfortunately, we can't actually see the accuracy number here, both because I haven't added accuracy to the custom tooltip yet, and I haven't rerun the weapon info generator with accuracy added. I tried running the generation command to get some accuracy values, but it seems I broke it somehow. Turns out, the issue is with my implementation of the generation method that doesn't take any material information. Having 0 for these causes dividing by 0 errors in some of the auto-generation formulas. A quick change to 1 instead of 0 should fix the problem. Again, I didn't do any kind of formal testing here, but the values seem to be what I'd expect, so I'm just going to assume it works. Now on to implementing accuracy for ranged weapons. Just as a reminder, accuracy for ranged weapons is going to work as a random deviation factor from the crosshair when shooting a weapon. But I also had the idea to make the damage bonus field for ranged weapons add to the velocity of the projectile, since arrows in Minecraft deal damage according to their velocity. To begin with, the method that handles shooting projectiles already has a field called inaccuracy. For players, this is always set to 1. For mobs though, it seems to be some function of the game's difficulty. I'm not sure about the exact math on how inaccuracy affects projectile trajectory, but from the name I'm assuming the higher the inaccuracy, the more deviation there is in the projectile's expected path. To be sure though, I'm going to test some different values to see how they affect things. So it looks like 0 inaccuracy causes the arrows to be 100% precise, as expected. On the upper end, an inaccuracy value of 10 is pretty bad, and at 15 it's pretty much unusable outside of melee range. Knowing this, what we'll do is just map the inverse of accuracy to a range of 0 to 15. So 100% accuracy would mean an inaccuracy of 0, while 0% accuracy means an inaccuracy of 15. To give a little more variety between bows and crossbows, and to justify crossbows' higher rarity, I want to give crossbows slightly higher accuracy than bows. This will also allow bows and crossbows from mods to be more valuable in ways other than damage. If we give bows 75% accuracy, that would equate to an inaccuracy value of 3.75. That's over 3 times the inaccuracy value as vanilla, so I want to test it first. I don't want bows to be super inaccurate, just slightly worse than vanilla. That seems pretty reasonable, so we'll go with 75% accuracy for bows, and keep crossbows at 90%, which roughly equates to vanilla inaccuracy. Now let's work on adding some velocity to arrows depending on damage bonus. Again, I'll start by checking out the method that shoots projectiles, and once again there's a parameter here that corresponds to velocity. For bows, velocity is given as the percentage the player has charged their arrow, multiplied by 3. For crossbows, it's 1.6 for fireworks, or 3.15 for arrows. Essentially, bows have a velocity of anywhere from 0 to 3, where crossbows are always 3.15, since you can't shoot them without full charge. This also means arrows from crossbows are slightly faster, which should also mean they do more damage. To be honest, I've never actually noticed any difference while playing. Have you? So I know what the default number is for velocity, but I don't actually know what that means. Does 3 velocity mean 3 blocks per second, or is there some kind of math here that translates the 3 to something else? We'll do some tests using different values to get a grasp on the scale of this number. What I mean by that is, will changing the 3 to 3.1 make the arrow fly at light speed, or do I have to change this to 100 to actually see some kind of meaningful difference? What I've found is that at 21 blocks of distance, the arrow flies completely straight at velocity 9 or higher. Though I'd assume that any given distance has some kind of threshold of velocity for the arrow to fly straight. Also, the elevation would presumably affect this. Though what we've just tested doesn't actually tell us anything about how velocity impacts damage. Final arrow damage is calculated as the base damage of the arrow, which is always 2 for vanilla arrows, multiplied by the speed of the arrow upon impact. And speed upon impact is calculated as the length of the arrow's change in movement vector. It isn't clear to me how exactly the velocity parameter here is translated to the arrow's movement vector though. So I'm going to test it again, but this time on entities. In hindsight, I could have just done this while I was testing velocity earlier, but I didn't think of it. Well, it seems kind of random. I'm getting values all the way between 12 and 19 with the same velocity. Also, the distance doesn't seem to make a difference in damage, even though I would assume the arrow should lose speed as it travels. Maybe I'm just not giving it enough distance? I'm not sure. I need to add some debug messages so I can see the actual movement vector the game is using. So, turns out there's a little variety in the movement vector, even with the same velocity. Though, the difference isn't enough that it should change the damage of the arrow this drastically. Also, there's conflicting math here. This arrow with higher velocity somehow did less damage than the arrow with lower velocity. After a bit of investigating, it turns out arrows that are considered fully charged are considered crit arrows, which have a random amount of damage added to the final amount. Looking now, it does say so in the wiki, but in the code documentation that I was reading, it just says that a crit arrow has a stream of particles behind it. I'm not sure why arrows work this way, or why the documentation doesn't say anything about it, but let's go ahead and remove that quote-unquote feature. Finally, some consistent values. Let's go back to testing damage. Well, it looks like the relationship between velocity and damage is exactly what you might expect. Higher velocity leads to higher damage at a linear rate. Doubling the velocity doubles the damage. Interestingly though, the distance of the arrow doesn't actually seem to affect the movement vector the game uses. I had thought that maybe my values were just getting jumbled by the crit arrow thing, but it turns out it either really doesn't matter, or again I'm just not shooting from far enough. Anyways, let's move on to how we can translate the damage bonus input from the JSON file to an actual parameter to use with this method that shoots the projectile. My first thought was to add damage bonus to the weapon's usual damage, then reverse engineer how much velocity we need to add based on that total. But after a bit more thought, I realized it's not unlikely that a mod would add an arrow that doesn't have a base damage of 2, which would mess up the whole calculation. I can't think of anything clever, so I'll just take whatever is entered in the damage bonus field and add it directly to the already existing velocity. meaning if a bow has a damage bonus of 1, the final velocity would be 1 plus 3 is 4 velocity. Of course, this means we'll have to make sure users know how damage bonus works for ranged weapons. As a final note, I'm not going to mess with mobs' accuracy or velocity. They already have some logic that modifies both of these depending on the game's difficulty setting. I don't really want to mess with that when it won't end up mattering in the end much anyways, and I also don't think it would be very fun to have skeletons be shooting at you with supersonic arrows. After one final test, the new features seem to be working as intended, but there's this weird visual bug where the arrow appears to shoot in the completely wrong direction, but actually ends up in the right place. I've actually encountered this bug before when playing a few years ago. I had made this spell with the Psi mod that would basically just shoot any projectile near me really fast in the direction of my crosshair, but the projectiles would all bug out visually in the same way. I hadn't gotten into Minecraft modding back then though, so let's see if I can do anything about it now. I did a bit of googling, and it actually turns out the guy who made Draconic Evolution has found a way to fix it. What I learned from his code is that there's a clamp on velocity in the packet that sends data from the server to the client regarding projectile motion. Essentially, when the server tells a client how the projectile is moving, if the velocity is over 3.9 or under negative 3.9, you get the aforementioned bug. To fix this, I just went to the packet itself and removed the clamp with a mixin. After testing, it seems to work perfectly fine, so I don't really know why the clamp was there in the first place. We should keep this in mind though, in case there actually is a reason for the clamp. Really quick before I get into tooltips, I want to add functionality for critical failure. Critical failure is meant to represent the chance of a weapon shattering or breaking when hitting a target, and the purpose of it, gameplay-wise, is to act as an additional balancing tool for weapons. Each attack type on a weapon will have a percentage chance to critically fail. When using that weapon, whether that be hitting something with a sword or shooting an arrow with a bow, that chance will be rolled. If it hits, the weapon will critically fail, causing it to lose a configurable percentage of its durability. Before getting to config settings, I want to update tooltips to work with all the new stuff we've just done. There's nothing very groundbreaking happening code-wise, so I'll just give a little summary of what I changed. For all weapons, we display the critical fail rate and accuracy according to attack type as a percentage. For ranged weapons specifically, the reach line is replaced with velocity in meters per second. I have no idea if the velocity we calculated earlier is actually meters per second, but the number looks weird without any unit there, so I just added it. Also, for ranged weapons, where it would normally say attack damage, we instead just display the word element split, since in Minecraft, ranged weapons don't have their own specific damage numbers, but they could still have an element split. By the way, if you're wondering where I got these icons from, I purchased them on itch.io from this guy called Siang Mu. Check him out. Last but not least, we'll get to adding some config options. I want to make as many things as possible configurable, and you guys have also already had some suggestions in the comments for what should have config options. Let's start with client-sided things. Castona here recommended that the custom tooltip font be toggleable. This should be an easy thing to do. We can just create a boolean value in the client-sided config, and then read that whenever we create a text component. Here's what the tooltips look like without the custom font. By the way, the custom font is Minimal Pixel by Munir Tohami that I've modified slightly to be more readable in Minecraft. Next up, Secutor0214 has requested that custom reticles be optional. This is totally understandable, since that feature isn't super integral to the general goal of the mod. This config option is slightly harder to implement since custom reticles are partially done by Mixin, and what I mean by that is the logical side, the part that actually detects entities, is done by a Mixin, while the visual side, the part that draws the shape on the screen, is done with Forge events. Earlier, I mentioned that Mixins can cause a game to not be able to load if two mods are trying to modify the same base game code. If we're going to make custom reticles toggleable, we may as well try and make it so that the Mixin isn't applied if the config setting is turned off, because it could potentially make the mod more compatible in the future. Unfortunately, Forge's inbuilt config system with TOML files isn't going to work here, because mixins are loaded before the config files are read. That's okay though, there is a workaround. What we can do here is just create our own JSON file in the config folder with a boolean value to load or not load the mixin. Since it's our own JSON file, we can choose to load it whenever we want. For the visual side of custom reticles, we can use the default Forge configs. I could just have the visuals read the JSON file that the mixin uses, but it's likely that users may not see the JSON file since it doesn't follow the same format as other config files. Leaving a setting in the normal client config ensures that all users are aware of the fact that they can toggle custom reticles. We'll make sure to leave a note here that if the user wants to disable custom reticles, they also need to head over to the JSON file and make sure it matches. I do recognize the fact that custom reticles are objectively an advantage gameplay-wise, and having that be a client-sided feature means some players on a server can play with it while some play without it. This is Minecraft though, not a competitive game, so I don't think it's too big of a deal. If there's demand for it, I'll try to find some way for servers to force the setting. Finally, two more very simple client config options are toggling mob health bars and damage indicators. Moving on to common configs, the first request here is an option to only allow weapons to have a single attack type. This actually doesn't need a config setting, since you can just come to the config files over here and remove any extra attack types, leaving weapons with only one. I also responded here saying there will be a config option to entirely disable attack types, but I changed my mind. Attack types at this point are too integral to the mod as a whole to remove. The other common config settings all have to do with combat. Here we have settings to enable accuracy as a feature in general, or only toggle it for melee or range specifically. Over here there's the option to toggle critical fail, or change the percentage of durability lost upon critical failure. Finally, we have the option to enable or disable lethality, and change the ineffective reach damage modifier, which is by default 25%. As a quick note, there's no need to make a toggle for the minimum reach setting, since you can effectively disable the feature by making the minimum reach of every weapon 0. Well, that's everything for today, guys. For the next video, I'm planning on adding a stat page, maybe with some kind of snazzy book UI. Thanks for watching, everyone, and have a good one.